Everything we see around us is in color because of the light from the sun. Sunlight is a mixture of colors, which, however, can be seen only when it is split up, by droplets of water, for instance, to form a rainbow. Let us imitate this effect by causing sunlight, or white artificial light, to pass through a prism. By mixing these colors in various combinations, we can make an infinite variety of new colors. If we add all of the colors of the rainbow together, we once more obtain white light. Surprisingly, this can also be done by mixing green, blue, and red light only. Furthermore, light of these three colors, if mixed in the right proportions, will give almost any other color desired. In theory, therefore, a color picture could be built up from green, blue, and red images only. This is, in fact, what happens in color television. Special filters in the color camera separate the picture into its three basic color images. These are then converted by the camera into electrical signals. These signals are transmitted to the receiver. There they are recombined to give one picture, apparently in full natural color. But if we examine the picture through a magnifying glass, we see only a pattern of green, blue, and red dots. There are, in fact, three images on the screen, one for each of the three basic colors. The dots are so small, however, that the eye cannot resolve them and sees only one multicolored image. The colors mix, then, in the eye of the viewer. The color picture is reproduced by the picture tube. The most important parts of this tube are the three-gun assembly, the neck with its cone, the faceplate with its shadow mask, and the metal rim band. The shadow mask fits inside the faceplate, which is coated with a fluorescent screen. Each gun provides an electron beam for its own color. These beams pass through holes in the shadow mask and hit the screen. Behind each hole there are three fluorescent dots, one green, one blue, and one red. The mask ensures that each electron beam can hit only its own dots, which then light up. This simple explanation of how the color tube works contrasts greatly with its complex manufacture. Manufacture begins with an accurately measured amount of glass, which is pressed in a mold to form the cone. Faceplates are pressed in the same way, one every 10 seconds. Before the faceplate is taken to the annealing oven, the supports by which the shadow mask will later be secured are fused in. The machine positions the faceplate so that each support is located exactly at the right point. The radius of curvature of each faceplate is measured electronically at 48 points. The outside dimensions, too, are checked for accuracy. The edge of the cone is precision ground to ensure a perfect fit with the faceplate. Thin metal sheets for the shadow mask. They are passed through a degreasing plant to clean them thoroughly. They then arrive in a dust-free room illuminated by sodium lamps. The photosensitive emulsion with which both sides of the sheet are now being coated is unaffected by this yellow light. The wet coating is dried in a carefully controlled atmosphere. Once dry, the photosensitive sheet is clamped in a frame between two negatives. Each negative carries a pattern of nearly 500,000 black dots. The sheet is now exposed to light through both negatives. During the exposure, the emulsion hardens and becomes insoluble. The unexposed dots are washed away to provide holes in the hardened emulsion for the etching process. The black dots on one negative are smaller than those on the other. Because of this, the holes in the emulsion are smaller on one side of the sheet than on the other. The etching process, therefore, makes tapered holes in the sheet. If the holes were cylindrical, some of the electrons would be reflected and thus strike the wrong phosphor dots. The tapering prevents this. The holes in each mask are checked for shape and size, both visually and electronically. Deformation of the mask is prevented by this reinforcing frame. To the frame are fitted the springs which will anchor the mask to the supports in the faceplate. The mask is pressed into the correct shape without any distortion of the etched holes. The mask and its frame are blackened in an oven. This makes for better heat dissipation when the mask is subjected to electron bombardment. Finally, the mask is welded to the frame. Back to the faceplate. This is thoroughly cleaned with a dilute acid solution and then rinsed with deionized water. The green, blue, and red phosphor suspensions are carefully prepared. The phosphor mixtures are prevented from settling by vibration agitators. They are checked just before use for specific gravity, viscosity, and electrical resistance. Moreover, every batch is color checked. A sample is taken from each batch, dried, and viewed under ultraviolet light, which reveals the color characteristic of the phosphor.